Hello everyone, welcome back to Imaginary Hub. In this class, we are going to study sorting algorithms. So when I say sorting, in the previous class we have studied about arrays, right? Here let us consider a array ARR is equals to, and we are having 5, 4, 1, 3, 2. These are the elements. Now you can see that the meaning of sorting here in this chapter we are going to study about sorting algorithms. So the definition of sorting is that either putting elements, either putting elements in in increasing order or in descending order. This is known as sorting. So here we will be given an array and we need to sort, we need to arrange elements in such a way that either it should be in increasing order or it is in decreasing order. If we can able to do that, then we can say that the given array is sorted. Now there are two different types of sorting algorithms when it comes to programming. One is user defined sorting. Here we will build our own algorithms, and we will see like we have 3-4 different algorithms which we will study in this class. And the next one is inbuilt sorting. In inbuilt sorting, what will happen is that we'll just give one single line like Arrays.sort. In the brackets we'll give whatever the array we want to sort, and automatically the sorting will happen. So in user defined sorting we will study few algorithms which are important to understand when it comes to exam point of view, when it comes to interview point of view. Okay, so the things which we are going to study in user defined sorting algorithm is, first is bubble sort. We will study about bubble sort, selection sort, insertion sort, and we will study something about counting sort. And there are different sorting algorithms as well, many user defined sorting algorithms like merge sort, quick sort, and radic sort. We will study this three sorting algorithms when we study a concept called as divide and conquer algorithm. So this is a separate set of algorithms. These are basic sorting techniques, right? And here in inbuilt sorting in Java collection framework, we have a line called as Arrays.sort, which is used to sort elements present in the array. So we'll pass ERR and automatically the sorting will happen. We will see. So first of all, let us begin with our bubble sort. Okay, so in bubble sort, what will happen is that, let's say that user has given me array let's say 5, 4, 3, 2, 1. Here the logic of bubble sort is that take the first element or take the largest element and push it towards the last. So what we will do is that we will iterate every element. Here we'll make turns. Let me draw the logic such that you will understand in a better way that here the given array is 5, 4, 3, 2, 1, right? So the basic logic is push the largest element to the last. Simple. So the logic of bubble sort is push the largest element to last of the array. This is the main logic of bubble sort. So what we will do is that in the 0th turn we will start our turn process. So here in the 0th turn we will compare 5 and 4, which is the greatest. 5 is the greatest, so we will push 5 in the 4th position. We will swap. So here 5, 4, 5, 3, 2, 1. After this again, what is the main intention? The main intention is to swap the largest element at the last. So the turning process, the iteration will continue until and unless we push the 5th element to the last of the array. So here we will take this element, we will swap it again. So 5, 3, 4, 4, 3, 5, 2, 1. Again we will swap 5 with 2. So 4, 3, 2, 5, 1. Again 5 with 1. So the final at the very last, the final iteration of this turn will be 1, 5. You can see 5 came at the last. Now this is the first turn. Now in the second turn, what we will do here is that we will take the element, we will start again iteration. So our new array is this 4, 3, 2 1 5. Now what will happen here? Let me come. Okay, so here you can see 4 3 2 1 5. Now what I will do is that I will compare these two, which is the maximum element 4, and it is in the initial position. If it is in the initial position, then swap it. So 3 4 2 1 5. Now again you can see among 4 and 2, 4 is the maximum and it is having less index. If this is the case, swap it again. So here 2 4 1 5, again between 4 and 1, 4 is greater. If this is the case, then swap. So 4 1 4 5, this is our like the end of iteration turn. Now in the third turn, what we will do is that 3 2 1 4 5, right? We will take this element, we will compare with 2. So here 3 is greater than 2. If this is the case, then swap again 1 3 4 5, and you can see here between 3 and 1, now between 3 and 1, 1 is less, so we'll put 1 here, 3 4 5, and now between 3 and 4, 3 is less than 4. If this is the case, then you don't need to swap, end the iteration, end the turning process here. Now in the fourth iteration, take this end of the array, which is 2 1 3 4 5, and swap 2 and 1, because 2 is greater than 1. So 1 will come here, 2 3 4 5, like this swapping will happen. Now you can see at the very last here the sorted element we got, like the sorted array we got 1 2 3 4 5, and how many turns we did? We did 4 turns. So can I say, if I write my pseudo code, that here I'll run my loop, I'm writing the pseudo code for I is equals to 0 to n minus 1, which is the size of the array. Now how many turns I am doing? I am doing n minus for, here I'll write for j is equals to, we will start from 0 to j should be less than n minus 1 minus I, because here you can see that how many turns we are doing. We are doing 1 2 3 4, and how many elements we have? 5 elements. So number of turns will be n minus 1. Here the total number of turns will be n minus 1, and we'll keep comparing till the nth turn. Here you can see the turn is 4, and we are comparing only 2 elements. So here n minus 1 minus I, the turn is, I represents the turn here, so we will compare only 2 elements. If n is 5, then 5 minus 4th turn, right? So here 4, it will give me 1. So we will compare only first element with the second element. This is how the turning process, and turning will start from not from 1 but 0. Okay, 0 1 2 and 3. So you need to understand that our iteration, the number of turning will be given by our outer loop, and in the inner loop we are comparing only the unsorted part. This represents only the unsorted part. Here you can see that we are comparing only 1 2, because the rest of the array is already sorted. The bubbles, the last bubbles are already sorted. That is why we are not comparing them. Now what we will do here is that if my ARR of jth element is greater than ARR of j plus 1, if this is the case, then I will swap ARR of j and ARR of j plus 1, as simple as that. Okay, like this we will do our turning process. Now if you want to understand sorting in a very like visual representation manner, then I suggest you a website that let me give you sorting visualizer, and this is the website. Now in this website you can visualize different sorting algorithms, right? So we have just studied bubble sort. So let me show you how it works. When I run it now, you can see, first of all we'll comparing 2 elements, again sorting, comparing 2 elements, sorting, comparing 2 elements, sorting, and you can see that in the first iteration, let me go a little back, let me come here. Okay, I don't know how to stop this. Okay, okay, you can see that the largest element came at the last. So the logic of bubble sort is that you keep comparing elements, and while you compare, push the largest element at the end, as simple as that. Now what I'll do here is that, let me code it. I'll zoom it and let me create a new folder called as sorting algorithm. Sorting. Okay, let me give 2. This is chapter 2, right? 2 dot sorting algorithms. Okay, and let me rename this array as well, folder as well, such that you'll understand in GitHub very clearly ki which folder is this, which folder is that. Okay, so 1 dot. Okay, now, okay, here I'll create a new file called as sorting algorithms, right? Okay, now this is not giving me error. I think it's a something file problem. Now I'll write public static void main string args. Now here what I'll do is that I'll just define my array key arr int arr is equals to, and I'll take the whatever the array like 54132. Okay, now what I'll do is that, first of all, let me show you ki how bubble sort works. I'll write a function public static void main. Okay, my bad, public static void bubble sort. So in bubble sort, what we are doing is that I'm like, the outer loop represents the number of turns. The outer loop is number of passes, or you can say number of turns. Okay, and the inner loop represents the comparison between each turn. Right here you can see that initially we are comparing all the elements, like if there are 5 elements we will compare all the 5 elements. Now in the second turn we'll compare only 4 elements, because I already know that the last element which is present at the last of the array is already sorted. Now in the third turn I will compare only 3 elements, in the fourth turn 2 elements, in the fifth turn 1 element. Like this my sorting will work. Now after sorting I'll create a function which will print the array. So I'll create a function, let me write it very top, public static void print arr, and here what I'll do is that I'll just print it. Now here I'll call my bubble sort and just save it. Now after print array, now when I run this now, I hope this should work. It is giving me some error, I'm not using it. Okay, it is not error, it's a warning. Let's see if it will work or not. Caused by Java lang library. Okay, let me clear it, clear, and right, sorting Java. Let me go into this folder first of all, sorting algorithms. Okay, there's no such directory. Let me copy this first. cd and this. Okay, I think we are good now. Clear, and run my file Java. Sorting, this should work every time some forward is happening with us, right? You can see we got the sorted array 1 2 3 4 5. Like this we sort the element. This is our original array, and after sorting my array will be like this. I hope you have understood key how bubble sort works. Now the next sorting algorithm we have is selection sort. So in selection sort, what will happen is that the second algorithm is selection sort. In selection sort, the main logic is we will take the minimum element, like we will consider that the whatever the current element we are at, we will consider this as a minimum element and will compare with the rest of the array. If you find this there is some element which is more minimum, then we'll swap them, right? So let me show you a diagrammatic representation, like 4 3 we have our array, right? 5 4 3 2 1, 5 4 3 2. Okay, why I'm taking a sorted array 4 5 4 1 3 2. Okay, let's say this is our array. Now let me write 2 properly, 2. Okay, now let's say in selection sort, what we will do here is that we will consider, we'll create an element called as current, okay, and we'll consider this as a minimum position. By default we'll consider it, and we'll compare with the rest of the array. So here you can see 4 is more minimum. If this is minimum, then we'll swap them both. So 4, 5, 1, 3, 2. Now what we will do is that we'll consider 4 as minimum now. So this will be my minimum position. Now what we'll do, we'll compare with the rest of the array. We'll compare with 4 with 5. Yeah, 4 is less than 5. If this is the case, don't swap, don't do anything. Now move to the next element. You can see 1 is minimum, then 4. So we'll swap these two. So my array will become 1, 5, 4, 3, 2. Now you can see that this is the rest of the array. This is my minimum position. Now you can see 1 is less than 5, 1 is less than 4, 1 is less than 3, 1 is less than 2. Yeah, it is less than every other element. If this is the case, then change the minimum position now. So what will happen is that we will put 1 aside, and we will take, this is our 1 aside. Let me draw it with a different ink. So I will put 1 aside. So here this will represent my sorted part. Now what I will do is that I will take the rest of the array. 5, 4, 3, 2. Now I'll compare this. I'll consider this as minimum, and I'll compare with the rest of the array. So you can see if this is minimum, then 4 is less than 5. Now I'll swap these two. So 1, 4, 5, 3, 2. Now here you can see that the minimum is this, and 4 is greater than 5. Move to the next element. 3 is less than 5. So here 1 will remain the same. Let me copy this. I'll copy this thing first. I'll copy this and let me delete it here. Delete and paste. Okay, now what I'll do here is that key 4 is less than 5. Yeah, minimum position is satisfied, but 4 is not less than 3. If this is the case, then I'll come here, I'll paste it. Now I'll choose my pen and I'll swap with 5, 4, 2. Now again you can see here 3 is not less than 2. If this is the case, then I'll write again 3. I'll swap with 3 with 2. So here I'll write 2, 5, 4, 3. Now you can see 2 is less than with the rest of the array. Now I'll put this inside this. So my array will become 1, 2, and 5, 4, 3. Here this is my sorted part, this is my unsorted part. Now this minimum position thing will continue until I get my sorted part. So let me show you. 1, 2, 5 is my minimum position. If 5 is minimum, then 4 is less than, so I will swap 5 and 5, 3. Now 4 is my minimum and 3 is less than minimum. So 1, 2, 3, 5, 4. You can see these 3 elements are sorted now, and I will compare these two. So 1, 2, 3, 5, 4. 4 is minimum, and like 5 is minimum position and 4 is less than the minimum position. Then swap them both. So 1, 2, 3, 4, 5. Like this my selection sort will work. Now what will the pseudocode of this is, I'll run my loop. For I is equals to 0 to n minus 1, and at each index I'll consider it as my minimum position. So I'll consider int minimum position is equals to I. Now I'll run my loop till n. So for I is equals to 0 to n, and I'll continue my loop. J is equals to I plus 1 from the next element, right? So here if you consider this as minimum position, then you're comparing the rest of array. So that is why my j will become j will start from I plus 1. Now here what I'll do is that if my minimum position ARR of minimum position is greater than ARR of j, then swap my minimum position array and j, right? Now after that like before swapping, you need to change minimum, right? So what I'll do is that I'll change the minimum position. I'll change minimum position as j. Now after doing this, I will swap my minimum position and my j. Like this swapping will happen. Okay, so here let me show you how selection sort works. We have array. Now when I start sorting, you can see that I'll take the minimum position, and if there is a element which is less than my minimum position, then I will swap them both. Okay, now again you can see, take the next element, consider it as your minimum position, and if there is any element less than this, you can see 11 is less than, then swapping will happen. Now 37, between 37 the element is 16, right? The minimum element is 16. Now what we'll do, we'll change the minimum position and swap them both. Like this the swapping will happen in selection sort. I hope you have understood how selection sort works. uh, just see the overall visualization, the representation of this. You can see finally we got our sorted array. Like this sorting will happen in selection sort. Like we'll take the minimum position, we'll compare with the rest of the array, take the minimum position, compare with the rest of the array. Like this sorting will happen. Now let me go to Visual Studio Code and write my code. Public static void and public static void. Let's say our function name is selection sort, so we'll write selection sort here. Now what we are doing, the outer loop represents the number of turns, overall number of turns we are doing, and first of all we will take the minimum position, and after that the inner loop represents finding the minimum elements present. Okay, like this our sorting will happen. Now what we'll do is that key will, so what we'll do here is that key will take the minimum position and will compare with the rest of the array, minimum position, rest of the array, minimum position, rest of the array. Like this sorting will happen. Okay, now let me save this, and here in the place of selection bubble sort, I'll write my selection sort. So selection sort, save this and run again. So here when I sort, now I'll get the same output, but now my selection sort will run. Okay, let me just run it. You can see that my output is 1 2 3 4 5. Like this selection sort will work. I hope you have understood. Now the next sorting algorithm we have is insertion sort. So in insertion sort it is very similar to uh, selection sort, but the only change is, like let's say this is our array. In insertion sort, what we will do here is that key, let's say we have array 5 4 1 3 2. So what we'll do here is that key, we'll take the previous element and the current element and we'll compare these two. If previous is less than current, then we'll swap them. Okay, so here we'll take these two elements, and in the among these two we'll compare which one is less. If the next element is less than the previous element, this is my previous element and this is my next element. Okay, if next is less than previous, then we'll swap them. So we'll swap 5 4 5 1 3 2. Now we'll compare this 2, this 3. Now we'll compare these 3. Now you can see that this 2 is already sorted, but 1 is not sorted, and we'll compare 1 with 5. Now 4, you can see 5 is greater than 1, so we'll put 1 here, and 5 3 2. Now again this will happen, 1 4 5 3 2. You can see this part is sorted, this part is unsorted. Now what we'll do is that we'll take it here and we'll compare now 5 3 2. Instead of 3 elements we'll compare 4 elements. Now we'll compare 5 is less than 3, then swap it, 1 4 3 5 2. Now you can see 3 is less than 4, swap it, so 1 3 4 5 and 2. Now you can see that this part is sorted, but this part is unsorted. Now what we'll do, we'll take this array, 1 3 4 5 2. Now we'll take this entire array and we'll compare it with 2. You can see that 5 is less than 5 is greater than 2, so we'll compare 2 and we'll put 5 here. Now like this swapping will continue until and unless we get the sorted array. 4 5, again put it here, 1 2 3 4 5. This is how our sorting will work. Okay, like this the given insertion sort will work. Let me show you a representation also. Representation are really helpful, like you can see the code, but if you don't understand what is happening, then it's just a bunch of time waste. So let me show you insertion sort how this will work. Run it. Now you can see we are comparing two elements first, after three elements, after four elements, then you can say swapping will happen, swapping will happen. This is a big array, that is why it is taking time. If I give a smaller array, then it will work perfectly fine. I hope you got the thingy how insertion sort work. You can see we got the sorted array. This is how insertion sort will work. Now let me go and write the code here. I'll write public, let me write public static void insertion sort. You can see in insertion sort what we are doing is that key, we are taking the current element and we are taking its previous element. Okay, and will match the correct position. If my j, which is my previous position, is greater than the current position, then what you have to do, you have to change the previous position and put the current element in the previous position. Okay, so basically you are taking the array, you're taking the element, and you're trying to see how in which position this element is fit, like fittable, or you can say you can insert. Like this insertion sort will work. Now in the place of selection sort, I'll call my insertion sort. So insertion sort, save it, and let me print it here as well. Remove this, and now print system dot out dot print. Okay, let me write, after calling insertion sort, I'll write it here. Okay, here system dot out dot print sorted array is this. Now save and run your algorithm. It will give sorted arrays 1 2 3 4 5, and this is happening through insertion sort. Like this insertion sort will happen. What will happen is that key will take the current element, previous element, compare them, current element, previous element, like this the thing will happen. And if there are multiple elements and this is our current element, will compare this current element with the all other elements. Like this insertion sort will happen. Now the final uh, sort we have is counting sort. Before going to counting sort, let me show you something very simple sorting algorithm. But before that, you need to understand key for bubble sort, selection sort, and insertion sort, the time complexity is big of n square. It takes quadratic, or you can say square time complexity, right? Big of n square. Now for better sorting and easy sorting, we have something called as inbuilt sort. Let me show you how inbuilt sort works. Public static void inbuilt sort, and what we'll do here is that we are writing all these things. Let me remove all this. We'll write inbuilt sort, and this is how we write our inbuilt sort. We'll just write arrays dot sort arr. I know this is very like easy peasy thing, only one line, and we're writing multiple lines on top, but the thing is it's really important to understand how things are working, the logic beyond bubble sort, insertion sort, and selection sort. It gives you a mindset. The main thing of DSA is mindset, right? We're not gonna do anything, any magical things here. So but inbuilt sort will give you this. I will directly sort this thing. You can run on your own. Within one line, we are sorting the entire array. This is amazing. And the time complexity of this is the time complexity of uh, Inbuilt sort is big of log n log n, and space complexity is big of 1. Let me save it. Now I hope you have understood. We have studied four sorting algorithms: bubble sort, insertion, selection, and inbuilt. Now let us study our final sorting algorithm of this class, which is counting sort. So in counting sort, what we will do here is that this is our fifth sorting algorithm, which is counting sort. So in counting sort, let's say we have our array 5, 4, 1, 3, 2. Now what we will do here is that key, we will take the maximum. The first step of counting sort is first step is take the largest element, So here the largest element is 5, so we will take 5 and we'll create a new array. We'll create a new array of size 5. So here we'll create 0, 1, 2, 3, 4, 5. Okay, overall 6 elements. So here maximum element is 5 and total number of elements the array in which we have created is n plus 1. N represents the maximum array. So here 6 elements: 0, 1, 2, 3, 4, 5. Okay, now what we will do is that in the third loop we'll take the element 5, 4, 1, 3, 2 and we'll start iteration. We'll start frequency of each element. So here initially every element will be initialized with 0, and this 0 is represents the frequency, or you can say occurrence of each element. Now we will start our iteration that 5, 4, 1, 3, 2. Now 5 is occurred one time, so we will change it to 1, and 4 has occurred one time, so 1, and 3 uh, 1 one time, and 3 one time, 2 one time. So you can see that each element has occurred one time. So what we will do here is that we will print the elements which has occurred. Like let's say that 1 has occurred 2 times. Let's say I have written 1 here somewhere. So you can see that in the entire array 1 has occurred 2 times. So we'll write like start iterating. So here we'll take first element, first index, which is 1, we'll print 1 and we'll change it to minus 1, which is 1, again 1, 0. Okay, now the next element is 2, it will become 0. We'll decrease the frequency when we print it. Okay, after 3 the frequency will become 0. We'll keep printing the element, that particular index, until and unless the frequency of that index becomes 0. Okay, again 4, 0, 5, 0. So 4, 5, like this counting sort will work. The only like drawback of counting sort is, although it is very easy to understand when compared to insertion and selection sort, the drawback here is that we are creating a new space. That is the only thing, and you should only apply counting sort for a small range of elements. Okay, now the drawback, again one more drawback is it can't be applicable to negative elements. For negative elements you have to do some modification, because indexing will not start from -1. If -1 is present, then how you gonna count the frequency of -1? Okay, that is the two drawbacks of these are the two drawbacks of counting sort. One is it is not applicable, this algorithm is not applicable for negative elements. Number two, it is only applicable for a small range of elements. Okay, got it. Now let me see key counting sort, how this will work. We have this array. Now I want you to observe key how this work. Let me give simple, and you can see key what we are doing. We have created n plus 1 array and we are putting the occurrence of each element. So yeah, like this counting sort will work. Let me go and print it here. So I'll write public static void and I'll write counting sort, and here you can see that the time is big of n plus k and big of k is the size. So first of all we are initializing the element, and like this the counting, we are calculating the frequency of each element and modifying the original array. Like this my counting sort will work. Now let me write print counting sort here, counting sort, save it, and it is showing some sort of error. Okay, save it and run. So you can see the sorted array is 1 2 3 4 5. Like this our sorting algorithms work. So in this class we have, let me zoom it a little out. So we have studied about bubble sort. This is bubble sort. This is selection sort. uh, Selection sort. Where is our okay, uh, inbuilt sort, counting sort, and finally we have studied about insertion sort. So total 4 algorithms and 1 inbuilt sorting algorithm. So I hope you have understood how each algorithm works, the logic, the visual representation of these 5 different algorithms. So with that being said, I will see you in the next class, and the next class is going to be on 2D arrays. It is going to be an interesting problem solving one. This is more of a theory and ideation one. The next class is going to be more problem oriented. So yeah, interested for the next one. See you in the next one. Bye.